This video covers the Lesson 7-4 warm-up for Secondary 1 Math. Warm-up 7-4. Solve for the missing length. Write your answer as a simplified radical and as a decimal rounded to the nearest tenth if necessary. Number 1. We're given this right triangle, and we are given that one side length is 8 feet, another is 12 feet, and then we have A. So we have to identify our hypotenuse. And remember, the hypotenuse is always across from the right angle. So here, our hypotenuse, or C, is 12 feet, which makes B 8 feet. So now we can use the Pythagorean theorem equation, since we have a right triangle, to find the missing side length. So we write our equation, A squared plus 8 squared equals 12 squared. So A squared stays A squared. 8 squared is 64, and 12 squared is 144. So we'll go ahead and subtract 64 from both sides of our equation, and we get A squared is equal to 80. Now we're going to take the square root of both sides of our equation and find that A is equal to the square root of 80. Now, we need to write this as a simplified radical. So we're going to go ahead and do our prime factorization of 80. So we have 80, and we're going to factor it down to 8 and 10. 10 factors to 2 and 5, while 8 factors to 2 and 4 factors to 2 and 2. So the prime factorization of the square root of 80 is square root of 2 times 2 times 2 times 2 times 5. And remember, we find those pairs of the same number multiplied together inside. We'll get one out. So we're going to have 2 times 2, which is 4, and have that 5 left inside. So we have A is equal to 4 square root 5, and that would be feet. And that's the simplified radical answer. Now we're going to find our approximation by just typing the square root of 80 into our calculator. So square root of 80, which gives us approximately 8.9 feet, because it was 8.94 and we round down to the 8.9. Number 2. So here we have 3 side lengths. We have a side length of 5 meters, another side length of 5 meters, and C. Now C is the hypotenuse, so we're just going to substitute 5 in for A and B in the Pythagorean theorem equation. So we'll have 5 squared plus 5 squared is equal to C squared. And well, 5 squared is 25, so we have 25 plus 25 is equal to C squared, or 50 is equal to C squared. Then we're going to take the square root of both sides, so we can find C, and we get that C is equal to the square root of 50. Well, we could type that right into our calculators and find the approximation. So go ahead, take the square root of 50 in your calculator, and we get 7.07. So this is going to be approximately, so C is approximately 7.1, and then we got to add our units, millimeters. Now to find the exact, since we came out as an approximation, we're going to find the prime factorization of 50, and that's 5 and 10 factors to 2 and 5. So the prime factorization of the square root of 50 is the square root of 2 times 5 times 5. Now looking for that pair, we see there's a pair of 5s multiplying together inside the square root, so we're going to get that out. So we're going to have 5 square root 2 millimeters is the simplified radical answer for the length of C. Okay, for 3 and 4, we're going to find the distance between each set of points using the distance formula. We're going to write our answer as a simplified radical and as a decimal rounded to the nearest tenth if necessary. So just like what we did, rounding and writing as a simplified radical in 1 and 2. So to find the distance, the first thing we got to do is label our points. So on number 3, we have 14, negative 5, and 9, 1. So we're just going to label that first point. So 14 is x sub 1, and negative 5 is y sub 1. Then on the next one, we'll have x sub 2 and y sub 2. And we're just going to substitute in those 4 values into our distance formula. So we're going to have the distance is equal to the square root of x2, which is 9, minus x sub 1, which is 14, squared, plus y2, which is 1, minus y1, which is negative 5, squared. Okay, so we're going to simplify this. So our distance is equal to the square root of 9 minus 14, which is negative 5, squared, plus 1 minus negative 5, which is 1 plus 5, or 6, squared. So again, simplifying that, we get the square root of 25 plus 36, which is the square root of 61. So now we would need to do our prime factorization here to figure out what the square root of 61 is. So 61, we're going to try to prime factor that. We would get, 61 is prime. It is not divisible by any other prime factor besides 1. So we're going to leave it as the square root of 61, but now we're going to use our calculators to find the approximation of this distance. So in your calculator type the square root of 61. And you get about 7.81, so 7.8. Number 4. So again we have the ordered pairs, 0, 8 and negative 6, 18. So we got x sub 1, y sub 1, x sub 2, y sub 2. And we're just going to substitute these into the distance formula. So the distance is equal to the square root of negative 6 minus 0 squared plus 18 minus 8 squared. So negative 6 minus 0 squared, that will simplify, and we get negative 6 squared plus 18 minus 8, which is 10 squared. So the distance is the square root of 36 plus 100, which is 10 squared. So the distance is the square root of 136. So let's first use our calculators and find our approximation if it doesn't come out nicely. So we're going to go ahead and type in square root 136 and hit enter. And we get that D is approximately 11.66, so, or for us, rounding to the nearest tenth, 11.7 units. Which reminds me, I should put units on the distance that we wrote down for number 3. So units. Okay. Now we got to find the prime factorization of 136. So I'm going to put that in the top corner here. So we got 136. We know that's divisible by 2, so I take 136, divide it by 2, and we get 68. And that's divisible by 2, which gives us 34. And that's divisible by 2, which gives us 17. And that's not divisible by 2. So just looking at our primes here, we got a 2, a 2, a 2, and a 17, which means we have a pair of 2's up here. I'll put this in yellow here. Pair of 2's, and then 17 times 2, which is 34. So our simplified radical expression for the distance D is 2 square root 34 units. This concludes the video of the Lesson 7-4 warm-up for Secondary 1 Math.